This is a meeting to help you start to create a construction takeoff for the hut assignment. Or sorry, for the hut building that I created. This is from week 30, and I will begin by showing you the assignment on week 30. So if we go to Blackboard week 30, we will see something similar to this. Calculate a construction takeoff. All right, you're going to use these three pictures to complete a takeoff. 1, 2, 3. And your takeoff, you're going to include the amount of 4x8 sheeting that you'll need for the walls and the roof, the amount of shingles, the bundles of shingles, and the amount of linear strip edge, and the number of 2x4 studs, 2x6 studs, and the plate that you'll need to construct those walls that are going to be inside. You can look at the notes here that we've taken, and then you'll submit all your work as a PDF, but you're going to organize your work first in a Google Sheet. Okay, so that's where we're going to go. We're going to go open up Google Sheet. Okay, so I'll switch over my screen to a Google Sheet where you'll manage your takeoff. So takeoff, what a takeoff really is essentially is you're looking at plans or specifications of a job, and you're seeing how much materials you'll need to build that job. Okay, the quantity of materials that you'll need in order to construct or finish that project. All right. So what I want you to do is first open up a Google spreadsheet. I'm going to title it your name, and then construction takeoff. And then also title it with your name down here. I'm going to put down the heading though first in one cell, and then tab over to type in my name. Tab over, skip that one, and then put the date as well. Okay. And then I will skip line and I'll put the project name. Okay. I'm going to name this the hut. The hut project, little hut that we're building. All right, now you're ready to kind of start to punch some numbers. After we label exactly what are the things that we are going to be looking at as far as the takeoff. Okay, and the first one is the amount of sheeting we need. So I'm just going to type that in here. All right, and then we've got roof edge. Oh, sorry, let's do shingles first. Shingles, roof edge, 2x4s, and 2x6s, and our plate. And now in order to find out, the amount of material we'll need for these, we're going to use calculations of area and perimeter. Okay, now we've talked about these. Area of a rectangle is going to be important, where we look at length times width. Okay, area of a triangle we'll also use, which is the base of the triangle times the height divided by 2. Don't forget about that, divided by 2. Okay, and now we're going to use our cells here to show our work. Right, so we've got this one here. And if we look back at the drawing, all right, we're gonna look back at the drawing here. I'm gonna look at my drawing up here, the exterior of my building where I got sheeting here. Okay, I'm going to need to calculate what the area of this rectangle is. All right, what the area of this rectangle is, and what the area of this rectangle on the roof is, and finally this triangle. Okay, those are all the flat surfaces that I'm going to need to cover with sheeting. I'm not going to worry about the floors inside at this time. Okay. So I'm going to take these one at a time. This first rectangle here looks like a nice big one. I can do first off here. So I don't have dimensions though for this rectangle on this view. So I'm going to scroll down here. I do have a dimension here. It's 12 feet long. I do not have the dimension of the height though. Okay, this would be a question you'd have to ask the owner. All right, hey, this drawing, I can't find where the height is. Can you tell me what the height is? Because it's not in either view. All right, it's certainly not on the floor plan. So then I'd ask the question, and the owner would tell you, well, it's 8 feet. Okay, so we're going to make this is going to be 8 feet. So we have a 12-foot rectangle by 8 foot. So on my sheet, I'm going to let the Google Sheet do all the work for me. It's going to be my calculator, and that way I can show my work and everything. To do that, I have to push equals because it's telling the Google Sheet, hey, I want you to do some calculations. Right? And then I type in what I want to do. Well, 12. And then I want to multiply, and you can use the star button on the keyboard to multiply 12 times 8. And I'm going to save myself a little work here. I could just push enter. Okay, that's one wall. And I could do the same thing over here. 12 times 8. Why did I do it twice? Well, because there's a wall on either side of the house that's this distance. Okay. So I could do that and keep doing more and more, each wall, each surface, okay, calculating the area, and then add them all up at the end. But save myself a little bit of time. I know I'm going to have 2 of these. So I'm going to go times 2. And delete this one. Okay, so these are those 2 walls opposite of each other that are 12 feet by 8 feet long. I'm going to go to my drawing again here. What other walls? Well, I've got this wall here, the other ends, right, of my building. These are only 10 feet long, though, and the same height, though, 10 by 8. So I go back to my doc. I type in equals. Tells my sheet I want it to do some calculating. 10 times 8 times, I got 2 of them. And there you go. There's the 2 answers. There's the exterior walls, the area of the exterior walls. All right, I'm not done yet, though. I now have to look at my roof. I have this rectangle here, and I have 2 of them, actually, with my roof here. So if I figure out the area of this, I can just multiply it by 2 to find the total area. Okay. I know one of the sides, the length, we can call it 12 feet. And I know the width, 7 feet, 8.5 inches. And so if I go back to here, 12 times, oh, wait a minute, 7 feet and 8.5 inches? How do I figure it? I can't do area calculations with different units. They all have to be the same unit. So I can't have feet and inches in the same calculation. So first I'm going to have to change. 7 feet, 8.5 inches into just feet and decimal part of a feet. Okay. All right. To do that, I got to do it in between step though. If I have half of an inch, I got to change that to a decimal first before I do anything. Okay, because when I put calculations in my sheet, it's just going to make our life easier. Okay. So I might know in my head already what a half is in terms of a decimal. 1/2 is 0.5. If I don't, I can take the top number, 1, divided by the bottom number in the calculator, and it'll give me 0.5. And just to prove that to you, if I use this as a calculator, 1, I use the backslash as a division, divided by 2, okay, that's it as a decimal, 0.5. Okay. So before I can even change the inches into feet, I need to get rid of this fraction. I don't want the fraction. Okay. So I'm going to change that to 8.5 inches. Okay. So we got 7, not 8, 8.5. 7 feet, 8.5 inches. Okay, now I can change this whole thing, 8.5 inches, into feet. How do we go from inches to feet? Well, we divide by 12. Okay, so if you take your calculator, go 8.5 divided by 12. I'm just going to use, this is my calculator, 8.5 divided by 12. Okay. All right, there's the decimal part of a foot that equals. So now I can say, well, this whole thing, 7 feet, 8.5 inches, is actually going to be 7 whole feet plus this decimal part that I just converted, 7.70833. So it's going to be 7.70833 feet is my other dimension of my rectangle. Okay. So I go back to here, instead of just plain old 7, it's 7.70833. Just get a couple decimals. And remember, I've got two sides to that. Okay. And if you notice, this is really, really close to some number. All right, it's really, really close to 185. All right, just a quick recap what I did there. I went over here. I saw that my roof had a dimension of 12 feet, 7 feet, 8.5 inches, right here. But I can't do this multiplication between this length and width because I have inches and feet both in this measurement. So I had to change this into decimal part of a feet. To do that, I had to make sure I didn't have any fractions first of all. So I changed the 1/2 to 0.5. And then I divided by 12, 8.5 inches divided by 12 to get the decimal part of a foot. Now, this is fine, what I have here. If you want to, though, get a little fancy, and by the way, I delete this stuff here because that's probably not what I want to see. If you want to get a little fancy, though, you could actually do all your calculations within the same cell. Okay, and I'm going to show you what I could do there. So 7 feet I have, and then remember what I did is I added, I'm going to put the parenthesis here because I need to do these calculations first. I had 8, and I'm going to plus 1 divided by 2. So that would give me 8 if I just selected this calculation right here. See how it says that's 8.5. So I took 1 divided by 2 to get 0.5, and that's in parentheses. That's the first thing I did. And I added to the 8 to get 8.5. Okay. And then I'm going to do one more set of parentheses because then what I did is I divided by 12 to change that into inches or feet. Okay. Now I can select this portion here. And you'll see that I got that same number that I came up with, 0.7083333. But I did all the calculations here in the same cell using parentheses to separate out the steps. Okay. And then I added that to 7, so I'm going to put that actually in parentheses as well. Okay. So now if I select those, 7.6, still at the right answer. Okay, so that's my decimal part of my foot. This is how many whole feet I have. And then what I did is I multiplied it by 12, so length times width times I've got 2 of them. And now if I push enter, I actually get a more exact answer, 185. Okay, which is really, really close to what we had before. Either one's fine. Okay, either one's fine. Now, last thing, we have a triangle that we have to figure out here. This little piece, that we're going to sheet that as well, put OSB or plywood on that as well. So if I go to, I've got a height, 2 feet, 11 and 3/8, and I've got 12 feet here. All right, now this is where I would make an assumption here, or do something here. 2 feet, 11 and 3/8 of an inch is very, very, very close to 3 feet because 11 and 3/8 of an inch is pretty close to 12 inches. All right. I could do the same thing that it, oh, sorry, you're not seeing what I'm seeing here. Okay. I'm on this drawing right here. This is the height of the triangle. I'm saying I would probably just round this to 3 feet when I'm doing my calculations. It's not going to throw my estimate off too far, and guess what? It's actually going to give me a little extra because I'm rounding up. So that's not going to be a big deal to me. I could do what I did here, this fancy calculation, right? But I don't think it's necessary. All right, it's really pretty close to what I need to do. This one was a little bit farther off, right? 8.5 inches is kind of in the middle of a foot. All right. So I didn't really want to round that one. But this next one I think I'm going to round. I'm just going to say equals. We've got a triangle that has a base of 12 feet and almost 3 feet high. All right, so I'm just going to multiply by 3. Now I do have 2 of those triangles, but remember the formula of a triangle. Don't forget you're supposed to divide by 2 after you do the base times the height. You always have to divide by 2. Don't forget triangles. You always got to divide by 2 after you do the base times the height. So if I divide that by 2, backslash 2, but then I realized, hey, you know what? I've got 2 of these triangles. So guess what? I've got to multiply by 2. So really what I'm doing, dividing by 2, multiplying by 2, those are kind of canceling each other out. Okay. You can leave them in if you want. You can not even put them to begin with, whatever you want. But your answer should be 36. And what I mean is, like, if I delete this, it's still 36. What I don't want you to forget is that when you have a triangle, you've got to divide by 2. This case, it didn't really matter because we had to multiply by 2, but because we had 2 triangles, but I want you to make sure and remember that, okay? All right, and that concludes this first section of doing a construction takeoff, and I will talk to you. Actually, wait, I've got one more thing. I apologize. I'm going to add one more thing. So to finish this off with sheathing, okay? With sheathing, we need to add up all these. So equals sum. We've done this before, and actually it's kind of already kind of estimating what I think what it wants me to do. But if it wasn't, you could do parentheses, and then you could select those cells and parentheses and push enter, and you get 573 square feet. And I'm going to put here sum, just to make sure I know what I did there. So 573 square feet. Now, sheathing, sheets of plywood come in 4 by 8, 4 feet by 8 feet on sheets. All right, so what is the area of one sheet? Well, it's 4 times 8. Okay. So each sheet will cover an area of 32 square feet. If I have 573 square feet total, and each sheet covers 32, how many sheets do I need? Calculation is equals the total amount we have to cover divided by the amount each one covers. And we see that we've got to have at least a 17.9 sheets. Now you can't have a 0.9 of a sheet. And in fact, you want to order some extras because you always make a mistake, or the sheets might not fit quite evenly on a particular space. All right, and it's up to you really to decide how much you want to calculate for waste. Okay, if you want to put 2 extra sheets, if you want to make it a percentage like 10%, okay, all that is up to you. All right, I should see though a number bigger than 18 for your final answer. Okay, so this is rough amount, and the final amount that I'm going to order. Okay, you don't have to do this, but I'm going to round up whatever that is, and then I'm going to just add 2 more sheets. So 20. 20 sheets. Yeah, over there. All right, and that concludes this the first part of the construction takeoff.